Hello, this is Jeff from Group 2 with Sudeep, Naveen, and NSI. So we will be discussing our baseball analysis. First, we will give you a quick overview of Sprint 1, and then we will share our Sprint 2 objectives. The third thing is we'll discuss the baseball eras, and we will show you how we selected our variables. And we will also be focusing on understanding the linear regression model. And we will also share our predicted analysis of the Blue Jays and the Yankees, and then we will end the presentation with the conclusion.
Hi, my name is Naveen. I'm doing a quick overview of sprint number one. In sprint number one, we have to select 8 different variables and create a box plot and histogram for all these variables. The task included that once you have the 8 variables selected, create a box plot and a histogram, perform a correlation analysis of specific fields within the complete data set, provide interpretation and analyze the result. For that, we created a Python chart where we imported pandas, numpy, seaborn, and pyplot. We negated all the null values in the table or the CSV file which we had received, and we selected 8 different variables. The 8 different variables we selected were strikeouts, doubles, triples, home runs under the offensive category. And in the defensive category, we had runs against, strikeouts allowed, saves, and home runs allowed. As mentioned in the task that we created a histogram for all these 8 variables, and the histogram showed us that doubles, runs against, strikeouts allowed had a symmetry. The others had a skew on the either side. We also did a correlationship for games won and games lost against runs scored, as well as for games won and games lost against runs against, which give us a very clear picture that a positive correlationship between games won versus games scored and a negative for games won versus runs against, which means that you're more like or a team is more likely to win matches when they score more and more likely to win matches when they concede less runs. For the next part, I hand it over to one of my colleagues who will explain you what do we need to do in sprint 2 and further. Thank you so much.
My name is Intisong, and I'm going to be taking you through a portion of the presentation. So, for the second sprint, we're trying to determine what made teams successful during 4 different periods in baseball, and those periods were range from 1871 to 1919, from 1920 to 1959, from 1960 to 1989, and from 1990 to 2010. And to do that, we'll be using a multilinear regression model. Um, and we'll also be doing a correlation analysis and to determine if teams were successful based on high offense or like just playing defensively, or if it was a balance of both that make them successful. And those years, those time periods were broken into different eras. So we had the dead ball era that was characterized by less scoring and just focused on like pitching and base stealing. We had the live ball era. We had power hitters, like prominent players like Babe Ruth, which a lot of us may have heard of. Then we have the expansion era, whereby the MLB was becoming a lot more inclusive and opening it up to different player styles and different player demographics. The post-steroid era, there was a high prevalence of PEDs during that era, so we'll see how the variables play a part in the various styles played in this era. And we did a correlation analysis to get our variables the games one, and this is it right here. So I'm just going to go straight into the correlation. So we used the Pearson method to find our correlation. So if I run this, you would see the values in line with games one. We're able to select at bats. We also selected doubles. We selected hits allowed, and we selected the fielding percentages. So as our offensive and defensive stats. Also, to justify the offensive and defensive variables, we did an individual linear regression model as well as a combination of both defensive and offensive stats to justify the selection of our variables. Let's see here. So this was the first one. We had the games one against the at bats and the fielding percentage. And we got our R square value, which is 0.63. You see the F statistic there as well. See the p values are close to 0. And then once we did the combination of both both four variables, both offensive and defensive, we were able to get a higher R square value. And yeah, it showed from this, it showed that it was multilinear. So basically, all four variables do play a part in us having games one, and how the intercept affects it. So basically, with these numbers being negative and the p-values being 0, if we weren't to get any games played, or if we got games played without any of these variables being in there effectively, we would have less wins. And the wins would be in the negative than it being in the positive. So there's a strong correlation between all four variables to games one. Thank you. And my next team member is gonna continue from where I stopped.
Hello, my name is Sudeep. I'm here to present about regression model analysis and the prediction part, which was our last question of the project sprint 2. So we can see our model summary created from 4 different time frames, which is from 1871 to 1920, 1921 to 1960, 1961 to 1990, and 1991 to 2010. So for the calculation of this regression model, we have used stat models library. And stat model library is a Python package that is used for performing statistical data exploration. So for this calculation, we have split the data into training and testing. For the training dataset, we have used 70% of the data, and for the testing, we have used 30%. So for calculating this regression model, we tried combining the possible variables from both the offensive and defensive, and this is the model where we obtain the best output, and this is our final model which has the good prediction for the game on. So and next thing we did is about creating the histogram of 4 different variables, and from the graph we can see that doubles is the only variable which is equally distributed. And the last question was actually about performing the prediction analysis of the 2 different teams, Toronto Blue Jays and New York Yankees. So I'll just show this calculation in our Jupyter notebook file. So this is our prediction analysis for the Toronto Blue Jays of their 2012 and 2015. So for this we have used fourth model which we have already calculated before. So the prediction for the year 2012 is actual game on was 73, and the predicted game on is 78.40, and the actual game on for 2015 was 93, and the predicted game on was 91.63. So similarly, we performed the calculation for the team New York Yankees. We use the same formula for this calculation, using the same year 2012 and 2015 for the New York Yankees too. So this is our prediction for the New York Yankees team. So the actual game won was 95 in 2012. Predicted game won that we obtained is 86, and for the 2015 it was 87, and the predicted game won we obtained is 85.12. And the last part is about checking the error for this actual versus predicted game won. This is how we calculated the root mean squared error, and the error seems a bit high, so there might be some error in our calculation for the prediction analysis. Thank you.
Okay, so now we have slide 19. We have the model performance by comparing actual versus predicted. So we found that the mean absolute error is 5.38, the mean squared error is 41.28, and the root mean squared error is 6.42. So to conclude, we noticed that refocusing on the equilibrium between the offensive and defensive variables yielded more accurate prediction of the outcome. Okay, so in our analysis, we found the variables with the highest coefficient, which shows its strong influence on offensive performance, was bats, and we found that doubles was the only variable that was equally distributed in our histogram. Thank you, everyone.